Welcome to Math Park. Today we are going to solve question number 9 to 15 of the exercise 9A. So we begin with the exercise. So children, if you are finding it useful, please do not forget to share with your friends. And if you are new to the channel, please subscribe. In question number 9, you are given ABCD is a parallelogram, ABL is a line segment, and E is the midpoint of BC. You have to prove triangle DC is congruent to triangle LB, AB is equal to BL, and AL is equal to 2DC. We start with the first part of this question. So we take in triangle DCE and triangle LBE. So DCE is this triangle and LBE is this triangle. So let us see what all things are given to us. So first thing, since E is the midpoint, you have CE is equal to BE. CE is equal to BE because E is the midpoint of BC. E is midpoint of BC. Okay, so first thing we got. The second thing we have, since DC is parallel to AL. Now DC and AL are two, ABL is a line. So we have this angle C is equal to angle B. This become alternate angles. So we have angle C of this triangle is equal to angle B of this. So you have angle C is equal to angle EBL. I cannot write simply B because there are two angles formed over here. So why are these two angles equal? Because they are alternate interior angles. Alternate angles with respect to DC is parallel to AL. Okay, AL because BL is a part of that. So these become alternate angles. The another thing, now we got two things. We got this side part equal. Okay, we got this angles equal. Now what do you say about this angle? What type of angles are this? So you can say that this angle 1 is equal to angle 2. They are vertically opposite angles because these two are intersecting lines. DL and BC are intersecting lines. So you have angle 1 is equal to angle 2 vertically opposite angles. So therefore you have triangle DCE is congruent to triangle LBE by which test? ASA. By ASA. Okay. So if the triangles are congruent, then corresponding parts. Now you are asked AB and BL, but AB is not the part of this triangle. But yes, DC is the part and LB is the part. So we get DC is equal to LB CPCT. Let this be my equation number 1. DC is equal to LB CPCT. And also you have DC is equal to AB because these are opposite sides of parallelogram. DC and AB are equal because they are opposite sides of parallelogram. Okay, so let this be equation 2. So what do you understand? DC is equal to LB and DC is also equal to AB. So therefore you get AB or LB is equal to AB, or you can say LB is the same as BL, or you can say AB is equal to BL, and this is how we have proved the second part. Okay, now for the third part, remember you have to focus on AL. So what is AL? AL is equal to AB plus BL, correct? This is the line segment. AL is equal to AB plus BL. Now AB, in place of AB, can I write DC from here? So in place of AB, I can write DC from here. So I get AB is equal to DC, and BL is also equal to DC from this part, from equation 2. So we get BC is, or BL is also equal to DC. So this is how you get AL is equal to 2DC, and we are done with the third part of this question as well. Moving to question number 10. In the given figure, you have AB is equal to DB, AC is equal to DC. In triangle AB, if you have ABD, this ABD means this complete angle is given as 58 degree. And DBC means only this part. DBC, this is 2x minus 4 degrees, only this part of an angle. Okay, and ACB is equal to ACB, this is y plus 15 is this part of an angle, and DCB is 63. So this part of an angle is 63. Okay, now you have to find the values of x and y. So we need to find the relation between these angles. So for that, we start proving these triangles congruent. So we say in triangle ABC and triangle DBC, What all things you have? You have AB is equal to DB. It is given. So you have AB is equal to DB. The next thing is given to you is even AC. Even AC is equal to DC is given to you. So also AC is equal to DC. These two things are given to you. What is the third thing you can see? This BC and BC is the common side. So we get BC is equal to BC is the common side. Okay, so three sides of one triangle are equal to the three sides of the other. So therefore, you get triangle ABC is congruent to triangle DBC by which test? By SSS. Got it? So if these triangles are congruent, you get angle AB, this angle, these two angles are equal. That is ABC is equal to DBC. Angle ABC is equal to DBC, CPCT. Okay. Now, if angle ABC is equal to DBC, your AB, so both of these are angles are equal. So D, you can have this, both of them are halves of angle ABD. So therefore, you get angle DBC is equal to half of angle ABD, as these two angles are equal, and which is half of 58 degree, that is 29. You got this? So what is angle DBC? DBC is 2x minus 4 is equal to 29. So you get 2x is equal to 29 plus 4, which is 33. So x is equal to 33 divided by 2, which is 16.5. So this is how you got the value of x. Now let us focus on this part. So since you have these two triangles congruent, this is first part you have taken ABC is equal to DBC CPCT. Same way you have angle ACB is equal to angle DCB again by CPCT, because you have proved these two triangles congruent by CPCT. Now what is ACB? ACB is Y. ACB, look here. ACB is Y plus 15. So y plus 15 is equal to DCB is 63. So you get DCB is equal to 63. So we get an equation. So y is equal to 63 minus 15. So y is equal to, you get 13 minus 5 is 8. Carry 1, 6 minus 48 degree. Got it? Number 11, you are given AB is parallel to FD. This is A. Can you see this mark? AB is parallel to FD. These two marks. AB is parallel to FD. The second thing you are given, AC is parallel to GE. So AC is parallel to GE. Okay. And you have to prove BG is equal to DF. BG is this part is equal to DF. Okay. And also you have to prove CF is equal to EG. So given to prove, let us note down. So you are given AB parallel FD and AC parallel GE, and BD is equal to CE. These two parts are also given equal. Okay. So to prove BG is equal to DF and CF is equal to BG, which triangles we should take? So we start with proving the triangles congruent, of which these are the parts. So we take triangle BGE. Start with BG. So in triangle BGE and triangle, if I take BGE, I'll start with D. So in BGE and DFC and triangle DFC, let us see what all things you know. What all things you know here? So in these two triangles, BGE and DFC, you are already given that AB is parallel to DF. So that is why you will get this angle B is equal to angle this part D. So let me name it as angle 1. They are the corresponding angles because these two lines are parallel and BC. These two lines are parallel and BC is the transversal. So you have angle B is equal to angle 1, which is they are the corresponding angles. Okay, because how corresponding angles? You have AB is parallel to DF. That is why they are the corresponding angles. The second part, if I look for these triangles, again of this triangle, when I look, these two lines are parallel. That is, you are given parallel AC is parallel to GE. At that time, you have this angle C is equal to this angle 2. Okay, because they are again corresponding angles. So now angle 2 is the angle of this triangle. So I'll write angle 2 is equal to angle C. Again, these are the corresponding angles because you have GE is parallel to AC and BC is the transversal. Got it? You got two things. Now, what is the third thing that we can have? The third thing we can have is something common. You have already given BD is equal to, you are given BD is equal to CE. This is the part, but this is not the part of this triangle. So if, how do I get BE? If I want BE, how do I get BE and CD equal? So I'll have to add DE to both. So we add DE to both sides. So we get BD plus DE is same as CE plus DE. And what is BD plus DE? BD plus DE is BE and CE plus DE is CD. And are these the parts of these triangles, BE and CD? Are these the part of these triangles? Yes. So this is how you get the triangles congruent by which test? Observe carefully. Just observe carefully over here. So looking at this, you can see that this is the part. Okay, angle. This is the angle. Okay, and in between this side and again angle. So by ASA, the triangles are congruent. If I look for this triangle, again, this is the angle. Okay, this is the side CD and this angle 1 of this triangle are equal. So this is how you get the triangles congruent by ASA. You get these two triangles congruent by ASA. So therefore, you have triangle BGE is congruent to triangle DFC by ASA, angle side angle. Okay. Now, if these triangles are congruent, then you have BG is equal to DF. Look at this correspondence. So therefore, you get BG is equal to DF CPCT. And also you get CF. Is the CF part? Yes. CF is equal to EG. Correct. So you get EG is equal to CF again by CPCT. Hence, we are proved with this question. We are done with this question. In triangle ABC, you have AB is equal to AC. Show that altitude AD is the median. So what is given? You are given AB is equal to AC and AD is altitude. That is, you are given AD is perpendicular to BC. It is an altitude. And you have to prove AD is median. So to prove AD is median, what does the median do? It divides the opposite side into two equal parts. That means what? That means you have to prove BD is equal to CD. Got it? So let's start with the proving of this triangle's congruent. It is easy. So we take in triangle ADB and triangle ADC. What do you have? First thing you have AD and AD is common. So you have AD is equal to AD is a common side. Second thing, you have this angle 90 degree because it is an altitude. So you have angle ADB is equal to angle ADC is equal to 90 degree because AD is altitude, that is AD is perpendicular to BC. And the third thing, you are given AB is equal to AC. Now, what is AB? It is a hypotenuse. So you write hypotenuse AB is equal to hypotenuse AC. So one side, one right angle and one hypotenuse are equal. So therefore, you get this triangle ADB is congruent to triangle ADC by RHS, right angle hypotenuse side. Okay. And therefore, you get BD is the part BD is equal to CD. BD is equal to CD. Now, if BD is equal to CD, that means this point D, AD is dividing BC into two equal parts. Therefore, you say AD is median of BC. It is the median of triangle ABC. Okay, AD is the median. Got it? Moving to the question number 13. In the following figure, you have BL is equal to CM. So you are given BL is equal to CM. So you are given BL is equal to CM. Okay. And another thing is you are given this angle as 90 degrees. These two angles are 90 degrees. That is, you can see that BL is also perpendicular. BL and BL is perpendicular to AD. Okay. And also you can see that CM is also perpendicular to AM. Okay. This right angle marks that you are able to see in the figure. Okay. You have to prove that AD is the median of this triangle. You have to prove AD is the median of this triangle ABC. If AD is the median, that means as the same as the previous question, you have to prove BD is equal to CD. You have to prove BD is equal to CD. So let us start with the proof of this question. So we say in triangle, which triangle shall we prove congruent? BLD and triangle CMD So you already have angle BLD is equal to angle CMD is 90 degree because they are the perpendicular shown here. This 90 degree mark is shown over here. Then also you have BL is equal to CM is given to you. This is given in the question. The what is the one more thing what we have? So since these two are intersecting lines, we can have these angles equal. Let us say angle 1 is equal to angle 2. Numbering the angles become easy. Otherwise, you have to write a longer name. So you have angle 1 is equal to angle 2 because they are vertically opposite angles. And therefore, you get the triangles congruent by AAS, angle side. So therefore, you get triangle ABLD is congruent to triangle CMD by AAS. Now, if the triangles are congruent, you get BD is equal to CD. So, therefore, you get BD is equal to CD by corresponding parts of congruent triangle CPCT. And hence, you can say that AD is median of triangle ABC. Got it? Question number 14. In the following figure, you have AB is equal to AC and AD is perpendicular to BC. BE bisects angle B. You are given BE bisects angle B, that is these two, angle 1 and angle 2, you can take equal. And B is and EF is perpendicular to AB. That means this angle is again right angle. That you have to remember. You have to prove BD is equal to CD. Now to prove BD and CD equal, we'll have to take which triangles congruent, that we have to focus on. So we start with the part of the proof. So we start with the first part. So let us prove the triangles in triangle ADB and triangle ADC. You have angle ADB is equal to angle ADC is equal to 90 degree. Correct? Because it is given AD is perpendicular to BC. You are given AD perpendicular to BC. Okay. Then we have AD and AD is the common side. We have AD is equal to AD is the common side. What is the third thing that we know? We also know AB is equal to AC. This AB and AC are equal. So we also have AB is equal to AC given. Now, what is AB? And these are the right triangles. These are the right triangles. So AB and AC, they are the hypotenuse. This is the hypotenuse. Therefore, you have triangle ADB is congruent to triangle ADC by RHS congruence. Now, if the triangles are congruent, the corresponding parts are equal. That means you have DB is equal to DC, or you can write BD is equal to CD. So this is how you get. Therefore, BD is equal to CD by CPCT, corresponding parts of congruent triangles. Hence, we have proved with the first part. Now we move on to the second part. For the second part, with ED and EF are the parts of which triangles we need to take those triangles. So we take in triangle, let us take EFB and triangle EDB and triangle EDB. So what thing you have? You have angle EFB is equal to angle EDB is equal to 90 degree, right? These two angles are right angles. Okay. Then the next thing we have angle 1 is equal to angle 2 because BE bisects angle B. BE bisects angle B, which is given. The third thing we have, if this angle and we have BE is equal to B is the common side. So we have BE is equal to BE is common side. This is the common side. Okay. And therefore, we have the triangles congruent by what? Angle side. So therefore, we get triangle EFB is congruent to triangle EDB by AAS, angle side. This is the angle, and this is the side. And therefore, you have EF is equal to ED, CPCT. This is how you get EF is equal to ED by corresponding parts of congruent triangles. Hence, proved the second part of the question as well. The last question of this exercise, in this question, you use the information given in the figure to prove this. So what is the information given? So let us note down what are the things given in the figure. So in the figure you are given AC is equal to ED. This is the one thing that we can see given. These are the markings that are shown. The next thing we have these two lines parallel. Can you see this? We have also given the BA is parallel to EF. This is another information. Also, you have angle ACB. This angle ACB is equal to angle EDF. EDF. These are the things given. Okay, and you have to prove this is the part. AB is equal to FE and BD is equal to CF. Now, AB and FE are the parts of which triangles? Of course, ABC and EFD, correct? So let us start in triangle ACB and triangle EDF. Okay. So ACB and triangle EDF. What are the things given? You are given AC is equal to ED. This is given. And you are given angle ACB is equal to angle EDF. These two things are given to you. The third thing we have to find out. So what we can find out? How can we find out? So what do you say about these two angles? Are they equal? Yes. So you have angle B. So with the different mark, you have angle B of this triangle is equal to angle F of this triangle because they are alternate interior angles. How are they alternate angles? Since you have BA is parallel to EF, BA and EF are parallel and BF is the transversal. This is how these two angles become alternate angles. So you get these triangles congruent by what? By AAS. So therefore you get triangle ACB is congruent to triangle EDF by AAS, angle, side. Got it? Which angle? This is angle, this is angle, and this is the side. Angle, and side by AAS. And therefore, you get AB is equal to EF, CPCT. So first part is done. AB is equal to EF, CPCT done. Now the second part, you are asked to prove BD and CF. So for that, let us take BC and also you get BC is equal to, if I take BC is equal to FD. BC is equal to FD, again CPCT. Okay, BC is equal to FD because BC and look, BC and FD are the parts of the triangles which you proved congruent. But you are asked to prove BD. So what should I do to BC to have BD? So I have to subtract this CD from here. So if I do BC minus CD, am I getting BD? Yes. So BC minus CD, we get this BD. Okay. Now same thing over we will do here from BD also, from FD also. If I subtract from FD, if I subtract CD, I am getting CF. Okay. So FD minus CD, we are subtracting CD from both sides. So FD minus CD, what we get as CF. So this is how we proved BD is equal to CF, and we are done with the entire exercise 9A. Children, if you like the video and if this is helping you, please do not forget to share this with your friends. And if you're new to the channel, please subscribe.